Welcome back to my YouTube channel, and in today's video I'm going to be talking about higher derivatives. Higher derivatives as um the topic says is, for example, instead of when we are dealing with the y, the x always, higher derivatives is when we have something like the square y over the x square, which, as you see, it is differentiating another differentiation, the square y dx square. You can also go upwards as the cube y, the x cube, the raised power 4y over the x raised power 4. It can keep going on like that. So that is literally what higher derivative is all about. So let me pick a particular question that we are going to keep deriving. So let's say we have y is equals to x raised power 4 plus 3x square plus 7. Now, they now ask us to find for the cube y, the x cube. This is what we are asked to look for. Imagine. So now, first of all, we have to find for the y, the x. The y, the x is equals to, differentiating this, we have 4x cube, then plus 6x plus 0, which will be omitted. So we have our dy dx. After looking for dy dx, the next step is to differentiate this again in order to get the square y dx square. So the square y dx square is equals to, differentiating this, we have 12x square then plus 6 the 1. So this is how we are going to have it. We have our d square y dx square, but they ask us to find for the cube y dx cube. So the cube y over the x cube is equals to, differentiating this, we have 2 times 12, we have 24x plus 0. This will be omitted. So now we have our the cube y dx cube. It is as simple as that. Whatever number you see here is the amount of time that you are going to differentiate it. We differentiated this 1, 2, 3 three times, which is the cube y. The number you see here is what the amount of times you are differentiating this. Let me pick another example like a trigonometric ratio. Let's say y is equals to sine x. So we all know that the y, the x of sine x is equals to cos x. So let's say we are asked to find for a trigonometric ratio. This trigonometric ratio can go as far as possible. It just keep repeating itself and changing signs. It can go as far as possible. So let's say they ask us to find for the raised power 4y over the x raised power 4, which means that we are going to differentiate it 4 different times. So we have differentiated this once as cos x, then our d square y, the x square, will be equals to, differentiation of cos x is equals to minus sine x, and then this is the square y dx square, the cube y, the x cube. We will get it as sin x is equals to cos x. So we have minus times cos x. And we have to find for the raised power 4y, the x raised power 4. We are going to end up having it as minus times cos x. The ratio of cos x is equals to minus sin x, minus times minus sin x. So at the end of the day, this will be equals to sin x. This is a pretty simple question. There are questions where you can have it more complex, but I decided to start with simple for you to grab an idea of what higher derivatives is all about. So this is all about higher derivatives. You can go on questions like questions like x plus 2 raised to power 4 and so on, and decide to derive it, decide to find for the differentiation more than twice or so.